Welcome to this video on stack versus heap in Java. Today, we will dive into the inner workings of the Java virtual machine and its memory allocation techniques. To help you better understand the difference between stack and heap memory, their key features, and how they operate in Java applications. Java uses a memory model divided into stack and heap. Whenever we decline variables, create methods of essential objects, the Java virtual machine allocates memory for these entities. In this presentation, we will focus on the key features of stack and heap memory, how they are stored in RAM, and their practice usage. Stack memory in Java is responsible for stack memory allocation and thread execution. It stores primitive data types and references to objects allocated in heap memory, following a last-in, first-out structure. As methods are invoked, memory is dynamically allocated, and it rings as methods complete. Variables within the stack only exist for the durations of the method. Once the method finishes, memory is automatically reclined. The stack is fast, thread safe, and isolation per thread. But if it overflows, it throws a stack overflow error. While heap memory is used for dynamic memory allocation, while Java objects and JRE classes are stored at runtime. Unlike stack memory, objects stored in heap memory are globally accessible across different parts of the application. The heap is divided into generations, the young generation, where new objects are created and managed. The old generation, which holds objects that have survived longer, and the permanent generation, which stores JVM metadata and runtime class data. Heap memory dynamically adjusts in size based on the application's needs, but if it becomes full, the JVM throws an out-of-memory error. To summarize the key difference, stack memory is of fixed size, faster in access, and primarily used for static memory allocation. Each thread has its own stack, making it thread safe. In construct, heap memory has a dynamic size and is slower in access. It is shared between threads, so synchronization mechanisms are necessary to avoid issues. In practical terms, stack memory is typically used for store primitive data types, checking methods calls, local variables, and reference to heap objects. On the other hand, heap memory is primarily used for creating objects and store data that needs to be accessible across variable parts of the application globally. Why? The access option in Java sets the stack size for each thread, while the XMS and SMX options in Java are respectively used to control the initial and maximum heap size. When they are used up, stack will throw stack overflow error, and heap will throw out-of-memory error. In conclusion, both stack and heap memory are vital for the performance and functionality of Java applications. Efficient memory management requires a deep understanding of when to use stack and heap memory. The stack is best for method execution and local storage, while heap is essential for global object management.